So we've seen the USD API in Python, and we've seen how the ASCII file format is defined. Next, we'll look at a real asset structure. And in this case, I have Alarm Clock Mike from Monsters University. Here it's been modeled in Maya, and I'll just go ahead and export the geometry and shading data. Now, if we go and look at the files that were generated, we'll see we have three files here. We have alarmclockmike.usd, that's the root model file, and then we have a shading and geometry file. The root model file and the shading file are ASCII, and the geometry file is binary. If we open up alarmclockmike.usd, we see here it's pretty sparse. We've declared alarm clock Mike and said that it's a prop, and we just reference in the shading and geometry files. So if we look in the shading file, we see here that we're using the variant composition feature to define a variant called shading complexity, and by default it's set to full, and that's essentially an LOD knob for users. Now if we look in the geometry file, as I said, it's binary, so we can't directly edit that in gvim, but we have a utility called USD edit, which takes any USD layer and edits it as ASCII. So this is incredibly helpful for debugging binary files where something goes wrong. So here we'll look at our binary file as if it were ASCII. And we can see we have alarm clock Mike in our transforms, and here we have a subdiv for one of the bells. And part of the purpose of this USD edit utility is that you can actually make edits directly in the ASCII file, and those will be preserved back out to the binary that you initially edited. So here I've added metadata documentation string, just as an example. And when I close and reopen the file, we see that doc string has been preserved. So that's pretty handy. And below we see the geometric data that we'd expect, verts, inverts, points, etc. So why did we split this out into three files? The purpose here is alarmclockmike.usd is ready to be referenced in anywhere in the pipeline, either into a set, into a shot, into a pose cache. It can be loaded directly into Katana, say, for example, to render. So that's kind of the root model file. And we've split out the geometry and shading files explicitly so that modelers can update the geometry file and shaders can update the shading file, and it's all composed via USD through references. So there's no need to do a rebaking step. These disciplines can kind of all work in parallel, and everything just remains live. We use a versioning system so that you can pin a specific version of an asset for a shot, say, for example, to control when changes are accepted or rolled back. So that's a real-world asset structure as we use it at Pixar for USD.